My name is Krzysztof Ciesielski. I came from Poland. I work at Software Mill as a Scala developer. And today I'm going to show you how to access Apache Kafka with Akka Streams in an elegant way with a cool library. So the hero of our presentation is called Akka Stream Kafka. Its previous name is Reactive Kafka. So it's an open source library currently maintained by Software Mill and Akka team. And so it's a library to represent Akka Streams as stages, represent Kafka as stages of Akka Streams. So I'd like to start with a short introduction to Apache Kafka. So how many of you are familiar with Kafka and its features? Okay, most of you, great. So this will be just a quick recap. Kafka is a piece of infrastructure, a message log, and so it's basically divided into topics where we can put messages with producers and read with consumers. And one of the most important features is that it's a distributed message log. This is why Kafka is so popular now, because it scales well. It can divide topics into partitions, which are put on different locations, nodes in a cluster. So when we have a producer writing to a cluster, the cluster will take care of dividing messages into partitions. And we have a consumer reading from a cluster. The consumer can be accessing the log without thinking about partitions. So the division into partitions can be transparent for consumers. And it's easy scalable because if we have, sorry, wrong button. If we have more consumers coming in, it scales dynamically by reassigning partitions to new consumers. So this way we can parallelize processing. So this is one of the most important features of Kafka. Also, we can also have like manual assignment. There are some business cases where Kafka where you can read from particular partition by a consumer assigned statically. So Kafka focuses on decoupling producers and consumers. And it's widely adopted now and often used in microservice kind of systems. And we saw a presentation by Gideon previously who showed that it's a perfect piece of infrastructure for managing communication between microservices. So another important thing in Kafka is acknowledging messages. So when we read messages from Kafka, at some point we have to acknowledge that the messages are processed. So there is a commit method in the client, the Kafka client, and we call commit with an offset number. So important thing in Kafka is that we don't commit each message individually. We can provide an offset number to say, okay, I have processed all messages up to particular offset. So in case our consumer goes down and the new one comes, it will start reading from the last committed offset. So let's see how the client looks like. The plain Java client has an approach of reading messages by direct polling. So when we use systems like JMS or some queues, we often see APIs implementing the observer pattern, for example. Here we have to explicitly tell Kafka, give me messages. And this poll method here is blocking. And this 100 is, in this example, is the timeout, after which the block will be released, and the function will return some messages that we can process. And in addition, we kind of cannot really well control how many messages we will get from Kafka. We can configure the number of bytes that the maximum number of bytes that can be returned by poll, but we just know that we get some number of messages, and we then can process them. So this example is not reactive at all, I'd say, and it's a while loop blocking, and that's why Reactive Kafka is a library allowing you to use Kafka in a completely different way. So Akka Streams, a short introduction. We had a great talk by Heiko yesterday about Akka Streams. It's a library for processing streaming data, providing a DSL for describing data transformation pipelines, so building blueprints and running them. Underneath, it uses actor model and implements the Reactive Streams specification. What's very important is that Akka Streams focuses on backpressure and asynchronous processing. And another important feature is that it comes with a very powerful test kit, which is not often mentioned. And I think it's very important because testing asynchronous code is very hard. Debugging is usually out of the question. If you want to test your streaming processing where you have asynchronous stages, you really need good tools to do that. And Akka Streams comes with a powerful test kit when you can describe assertions and build elegant, simple tests for most of the cases. And it's, of course, extensible. So you can write your own library for connecting with Akka Streams and providing stages representing different kinds of sources. So a stream in Akka Streams consists of elements. We can say that there are three main types of elements. There are sources, flows, and sinks. So source is an element which doesn't have an input but has one output. A sink has one input, no output, and a flow has inputs and outputs. And there is this Alpaca project, which is basically an initiative to build a rich set of connectors. So if you go to GitHub and find Alpaca, it's just a big repository with many modules, which are libraries, for connecting with Akka Streams. If you want to connect to HTTP, streaming TCP files, different kinds of queues, databases, everything, and of course Kafka. But Reactive Kafka is a project outside the Alpaca repository. But still, it represents one of the Alpaca connectors. It's quite a sophisticated connector, and we'll shortly see how it works inside. To translate this blocking and imperative paradigm of polling messages from Kafka into a reactive API compatible with Akka Streams. So here's our stream, and we may want to read from Kafka, the first example. So underneath there will be a consumer. We may want to write to Kafka, so we will have a sink, which is backed by a Kafka producer. And another very common pattern is to have Kafka as a flow, which means that you process messages in your stream, put them in Kafka, and wait for acknowledgement, and then messages flow further down the stream. So here's an example of Reactive Kafka API in action. Unfortunately, there are some parts highlighted, but we can't see it here. So this upper part is not really very important. It's just initialization with connection parameters. So here's what's the most important thing. It's the consumer object from Reactive Kafka API and its plain source method, which will create a source, which is an Akka Stream source, emitting messages from Kafka connected with these parameters. The rest of the stream are just further stages of processing. Here is just like one stage, map async, doing some processing. If you're not familiar with map async, if you know map from Scala collections, then map async is something similar. But you can call asynchronous functions and provide a parallelization parameter, which will define how many parallel processing executions you want to have. And at the end, we run the stream with a sync ignore, which is just an empty sync, discarding messages. Yeah, so this is the, let's say, equivalent that we saw earlier with the plain API, doing a loop, polling, and processing. So there are many problems with such approach. If you want to add asynchronous processing here, if you want to have proper error handling and proper back pressure, then it would start to become very complicated. And I believe that eventually we'll start reinventing Akka Streams anyway. Here, the Reactive API allows just to declaratively create a source and then further declaratively process messages, define your processing pipeline without caring about timeouts, without caring about blocking. Okay, so the back pressure is one of the most important things. Each stage, each stage in a stream can hold back the upstream while processing. So this is back pressure. So some stages can be back pressure aware, like sources, which should emit messages accordingly to the possible processing power, let's say, of the rest of the stream. And some stages can be generating back pressure, like sinks or flows. So messages flow down the stream, and we can say that there is a demand flowing up the stream, like a flow of information about the processing capabilities of the stream, of further stages. So each stage is notified about the demand of further stages, and it also propagates its demand further up the stream to the source. So let's see how it works underneath. And so for you, as the library user, there's just a source, right? So you have a source which provides messages one by one, and it handles demand. Underneath, there is an Akka actor, which does the dirty direct poll calls to the vanilla API of Apache Kafka. And there is no while loop, obviously, because while loop is not asynchronous. So to do a kind of asynchronous loop in Akka, we can use a message sent by actor to itself. So if an actor sends a message continuously to itself, it can repeatedly, asynchronously repeat the poll calls to the consumer, handle messages, batch them, and do many other things that you don't need to care about. So from your perspective, you just get messages from the stage. And what's very important here is this dotted line. This means that there is a dispatcher, which is a dedicated dispatcher, isolating this whole thing from other thread pools. A dispatcher in Akka is like an execution context, or like a thread pool, for example. So by defining custom dispatchers for actors, we can isolate some part of the system, and then make sure that the rest of the system isn't affected in case of problems with using threads, especially in a blocking way. So this is called the bulkhead pattern, and very important tool in your reactive toolbox, so to say. So if we compare the while loop, constantly polling, and the plain consumer that we saw a while ago, we did some benchmarks, and there is practically no overhead. So we get almost full speed. But reading with the plain source is often not enough, because at some point, usually we would like to commit messages in many cases. So as we saw earlier, there is a commit function method on the Kafka direct API, which we should call from time to time. And let's see how it's resolved underneath. So to be precise, it's not commit, it's commit async that we use. It's a method on Kafka API that requires providing a callback. And most developers don't like to deal with callbacks, especially in Scala, where we are used to using futures and async reactive APIs. Dealing with callbacks is cumbersome. So also in case of Kafka, the poll calls and commit calls have to be synchronized in a very specific way. And having to know about that internal nuance is really painful for developers. So it's all managed by the consumer actor, because actors in Akka have this synchronization for free. They process one message at a time. For you have still just a source stage emitting messages, but on each such message, you can call a commit method, and for you, that will return just a future. But underneath, it will call asynchronously a commit. It will send asynchronously a commit message to the actor, which will deal with committing. Let's see an example. So this is called a committable source. We create a committable source with the consumer API. We then do some processing, which in this case is updating some database records, for example. And then we can get the message after this stage, and in the next stage, call commit Scala DSL on this message. The name is quite unfortunate, Scala DSL in the name, but it's caused by some problems with having common code in Java and Scala DSL, and we are working on resolving this. Anyway, this is an asynchronous call, returning a future. So we run it in map async. We can parallelize this if we want. And that's all. That's how we commit. If you would like to commit with the direct API, then here's an example with commit sync. Because if we wanted to use async here, we would need to provide a callback that wouldn't fit on the slide. So this is a very simple example, not necessarily the equivalent, but kind of. So when you get messages from the poll call, remember that this is not a single message, but a bunch of messages. So again, another blocking imperative loop of processing and then committing. But often we don't want to commit each single message. In many cases, we would like to commit to leverage the possibility in Kafka to commit, providing an offset number and telling it that we want to commit messages up to a certain offset. For example, periodically or after we accumulate a batch of messages which are processed. So if you would like to model this with the direct API, then we can introduce a buffer. And when the buffer is accumulated and it exceeds some limit, we can then call the commit and clear the buffer, for example. With Reactive Kafka, there is an API for it. It's another kind of, it's the same source, committable source, but we can process messages and not commit each single message, but accumulate a batch using grouped within, for example. So grouped within is a stage of Akka Streams available out of the box in the API, meaning that this will accumulate messages from previous stage until it reaches a limit or some time passes. Very useful thing. So in this case, we accumulate our batch. This stage will then emit a list of messages. And then we can fold this list into a special object of type committable offset batch from Reactive Kafka API. And this map stage will fold the list, emit a single object being a batch, and then we can call commit Scala DSL on the batch after we gather the messages. This is very useful for implementing at least once delivery semantics. If you want stronger guarantees, like exactly once delivery, it's also possible, but you have to probably write Kafka offsets somewhere in your database, and it's a more advanced topic. But at least once delivery combined with some kind of deduplication, it's usually a kind of effectively once delivery. Okay, so we also did some benchmarks, and the batched consumer using Akka is a bit slower than just a dumb loop doing while repetition and for each repetition. But still, the overhead is not too big. And remember that this is a single node. So if you want to have thousands or hundreds of thousands or millions messages per second processed in a cluster, I guess it's not a problem with Reactive Kafka. And batched commit. OK, now the producer. The producer is simpler than the consumer. So this is the vanilla API. There is a producer type with a send method. So we can send a record, and we have to provide the callback. And inside the callback, we have to deal with response. Either the message can be acknowledged or rejected, or there may be a timeout. So we have to handle this here in this callback, which is executed on the same thread where we executed send, which is not that obvious from documentation. You have to find this information somewhere deeper. So with Reactive Kafka, you can just create producer.plainSync and put it in your stream. So the upper part is just some Akka stream, some source, some processing, then creating producer record, and in the end, we just put our sync, which will write to Kafka and then generate back pressure according to acknowledgements from Kafka, which can be configured. If you don't want acknowledgements, you can disable them. If you want stronger acknowledgements, you can configure that in producer settings. OK, very common case, producer as a flow. We have a stage for that, which is producer.flow. Again, we put it inside the stream using the via combinator. So here, the stream has some source, some sink, and somewhere in between, we can use via and put our Kafka element here. And we don't need to care about callbacks, about error handling. Sorry, not error handling, but blocking calls, anything like this. OK, and now one of my favorite cases is when you would like to have back pressure per partition. Sometimes on a single node, you would like to read from multiple partitions, but you may want to have back pressure individually for each partition, because some partition processing may be slower than others. So for this, you can have a stream of streams. This means that there is a Kafka source which emits streams, and each such represents a set of partitions for a particular topic. So when there is a reassignment in the cluster, and when your consumer gets new partitions assigned, there will be a new element emitted by this outer source. And once there is a partition revoked, then such subsource will be closed. And it is called committable partition source, emitting. So here below is its type. It's a source of sources in general. It emits tuples of streams and additional metadata about topic and partition to which it is assigned. So this map function this call is processing streams emitted by the stream. So each element is a tuple, topic partition information, and an inner source. And here we can internally call map async on the source and do our processing. And this will provide us per partition backpressure. And finally, we can call flat map merge, which is another cool stage available out of the box in Akka Streams. So we have a source of sources. Flat map merge will create just a single source of elements. So it will merge back the stream of streams into a stream of messages. And finally, we can do the commit here or batching with group within, whatever we need. And now we're handling. I'm not sure if Heiko mentioned that yesterday. Probably yes. In Akka Streams, there is this notion of materialization. If we have a stream, it's just a blueprint. It's just a definition of processing pipeline until we call the run method on it. And then things get real. So this call returns a value, and it depends on the source and the sink what kind of type this value will have. And it is called materialized value. So in case of our source, the materialized value will be a pair of elements. One is a future, which shouldn't fail, and shouldn't complete and or fail. It's just like something like never-ending future. But we can put an on-failure handler on it and handle errors here. The other object is control, which we can use to gracefully shut down the connection. For example, if we want to have some code responsible for closing all the resources when the application is closed, then we can use the control there. And one of the recurring question is, what should we hear? How should I handle failing stream? What does it mean that the stream failed? So in case of Reactive Kafka, it usually means that it internally tried many times to connect and couldn't for some reason. So one good option here would be to keep the stream running in an actor and then just killing this actor from inside. So this can send a poison pill to the actor, for example, and then you have supervision strategy around the actor, which will try to recreate it and then reconnect. So there is this back-off supervisor in Akka, very useful thing. If we have an actor, stream wrapper actor, for example, which is an actor running our stream, and there is a failure inside this actor, we handle it with killing the actor, and we wrap this actor with a back-off supervisor. It will try to restart the actor using back-off retries. So it will retry with exponential back-off, I believe, trying to recreate the actor after 3 seconds, then a bit longer, until it reaches some kind of a limit. So it is a very useful thing for dealing with failures in Akka Streams in general. There's also Java API. In case you are not lucky and you have to work with Java and you would like to access Kafka in a reactive way, there is a Java API, which is still very simple, but sometimes you have to, write fault by yourself or things like this. But this example is the committable source that we saw earlier, so it looks almost like the Scala code and fits on one slide, which I think is a good indicator for Java code. So the Java API is there, you can use it. It has commit Java DSL function. And there is also another library, which I would like to mention here, which is called Kafka Streams. So it may become a little bit confusing for you. If there is Akka Streams, there is Akka Stream Kafka, and there is Kafka Streams. So this library is created and maintained by Confluent, which is the company behind Apache Kafka. And it's a Java library for streaming, processing messages from Kafka. So it sounds like it has the same purpose. But it doesn't. It has different emphasis. So we'll see shortly. Here's an example of word count taken from Kafka Streams webpage. So here we have some kind of a source, which is called KStream. Then we build also a processing kind of a pipeline here, which will group words read from a file, count them, and then write to some kind of a sync. But there are some differences. So Kafka Streams is Java only so far. I believe I saw on the web page that they are working on Scala API. And it focuses on stateful processing. So if you have a processing pipeline which requires you to do aggregation, stateful processing, windowing, joining, things like that, Kafka Streams offers API for that. Underneath, it can use some kind of persistent storage, and you can run your aggregation functions on it. While Akka Stream Kafka is, of course, mainly Scala DSL, with more sophisticated backpressure and focusing on async processing. And if you already have Akka in your project and Akka Streams, then integrating Kafka with your app is much simpler with Akka Stream Kafka. Yeah, the backpressure in Kafka Streams is just processing one message at a time. When message leaves, goes through all the stages and leaves the stream into the sync, then the next message is processed. In case of Akka Streams, you can have async stages, more sophisticated graphs of processing. So there, the backpressure can be more advanced. Okay, that would be it. And do you have any questions? Okay, thank you. See you around.